Hi guys, how you going? Mr. Bennett here. Welcome to Stage 2 Physics. I'm just going to go quickly through the requirements of the course in this video. Hopefully that will make it quite clear what you're expected to do. So the first thing, if you're looking at our learning requirements for Stage 2 Physics, it's expected that you will, as a physics student, work like a physicist. So if you're thinking about the expectations of the subject, well, students are expected to do the following things: identify, formulate question, hypothesize, understand concepts and the purpose, and obviously to investigate physics. Alright, so obviously be a bit structured this year, but ideally that's what you would do as a physicist in the real world. Alright, so you'll need to design and conduct collaborative and individual investigations in physics. So obviously using some equipment. So I'll obviously be using the Pasco gear. You need to represent, analyse, interpret, evaluate, investigate in physics through the use of technology and numerical skills. Alright, so that's obviously including things like doing the prac work, doing your tests. Alright, so select, analyse, evaluate the evidence of physics from different sources. So present an informed conclusion, discussion of contemporary physics applications. So there we'll be looking at things like doing some research, doing some essays, and that there is a major information search that you need to do next year. Communicate knowledge and understanding of the concepts and inform physics using appropriate physics terms and conventions. So that's talking about using the language of physics and understanding what those terms mean. Demonstrate and apply your knowledge of and understanding of physics to a range of applications and problems. Alright, so that would be more of the type textbook sort of stuff that you'll need to do. So when we start looking at the evidence that we need to collect over the year, the following things basically stick out. Alright, so we have two types of assessment types. The first one is an investigation folio, which will count for 40% of your marks. And generally what we'll do for that is we have 3 pracs. Right? One of those will be a design prac, and then we also have one issues investigation. So that's where you do your research and you present that information there. So we'll definitely go through that in the beginning of the year, so you can start working on that as we go through. Assessment type 2 are the tests. Right? They count for about 30% of your marks. So generally we'll have 1 test per topic. That's how it works. Alright, so then obviously the other part of that is you have a 3-hour exam with 30% of your marks at the end of the year. Alright, and that's set by SABSA, alright, the SACE board, and that's marked by them. Now let's quickly go over the contents of the year. Alright, so we have 4 major sections that we work through: motion and 2D, electric and magnetic fields, light and matter, and atoms and nucleus. So the first topic we'll be starting off with is projectile motion, which we did a fair bit of last year. And then we look at uniform motion, some of that will be new. The gravitation and satellites, that's certainly fairly new. And then the momentum and 2Ds, which will be an extension of what we did last year. Then when we come to the second topic, we do electric fields. Alright, so application of static electricity. Then we've got our motion of charged particles and electric fields. Alright, so we use an application called a cyclotron. And then we've got our magnetic fields, the moving coil loudspeaker, and how that works using the right hand palm rule. And then our last topic there is motion of charged particles in magnetic fields. And then again we go back and look at the cyclotron and how that works. So the key thing about when we're doing our topic, we simply have an application that relates to that you need to know about. Alright, so our third topic, light and matter, we do looking at electromagnetic waves, and the example there is our LAD system. Alright, so which we use to survey oceans. Then we look at the interference of light. So the application there is how we read a CD or a DVD. And then third topic is photons. Application there is obviously X-rays, and then the wave behaviour of particles. We look at electron microscope and how they work. All right, so It's very interesting, I think, the whole course itself. When we come down to the last topic, the atoms and nuclei, the structure of the atom. Alright, so we talk about how lasers work in the application there. The structure of the nucleus. We're looking at radioisotopes, and we're looking at a thing called a PET scanner for that as an example. And then we finish off with our nuclear fusion, and then the application that is a fission nuclear power station. Alright, so in terms of the whole course, it's really important for you to understand that they are the topics that you're doing. Alright, so what are your responsibilities as a student? Well, you need to present for assessment, formative and summative assessment work, and it's part of your responsibilities to negotiate deadlines to meet obviously the internal deadlines, but also the final deadlines of the SACE board. And obviously if you have an illness or it's a major problem, you need to let me know. It might be necessary to have a medical certificate for that as well. Now when we start looking at your performance standards, alright, so you'll get a copy of this, and we're going to do an activity in the beginning of the year looking at how you interpret this performance standard. But really important that you understand how this works, so that you can make sure that you're trying to do the best that you can to work at the A standard. So I want you to understand the difference between the A, the B, the C standard and what's required, so it's quite clear for you. So you will know when you're critiquing your own work and when you're getting others to critique your work, that you will be able to go, oh yeah, that needs to be a bit more thorough there, or it needs to be, doesn't have any of this sort of stuff that you need to work at that higher level. Anyway, I hope this sort of helps you get a bit of a feel for what we're doing for the year in terms of physics. It's a really, really awesome course, and I certainly love teaching it, and I hope you will, as a student, really enjoy working through the topics that we do.